One of the last topics of equilibrium is LeChatliers's principle. This is by far one of my favorite things to do. LeChatliers's principle states that you can change the equilibrium depending on the conditions. Okay, and so if you change the condition, then the equilibrium will shift to accommodate that condition. So this problems over here, you have two problems here for you, question 1 and question 2. So these two problems deal with those two, with that change, okay, that you might see. So here is an equation, PCl5 gas to give PCl3 plus chlorine gas, and delta H is given to us, which is plus 92.5. Plus 92 means that it is endothermic, right? Exactly. So it's endothermic. If it was negative, it would be exothermic. So plus 92.5 means endothermic. Okay, so predict the direction of the equilibrium under the following change of conditions. So we have to look through all of these conditions and see what happens to the equilibrium. The first one is the temperature is increased. If the temperature is increased, then what will happen to the equilibrium? Well, to see the temperature change, then you have to see the delta H. So delta H says that the reaction is endothermic. So if delta H shows endothermic reaction, it means that heat is a reactant. If heat is a reactant and you're adding a reactant, then reaction will move forward. Okay, so heat is the reactant, and if you're adding reactant, then reaction will move forward. If more Cl2 is added, more Cl2 is product. So if you're adding more product, that means that you will shift your reaction back to reactants because you just added more of the product there. So it will shift to compensate and then form more product, more reactant. Yeah, strange. Okay, so this is A, B, C then. Some PCl5 is removed. So PCl5 is reactant. Okay, and so if PCl5 is removed from there, then it means you're removing the reactant, and if you're removing the reactant, it means that reaction will go back, okay? And if it goes backward to reactant to compensate for that, okay? So that is if PCl5 is removed, okay, from there. Now let's talk about pressure is increased. Now pressure increase has to do with moles, okay? So moles of reactant is equal to 1, moles of product is equal to 2. So when pressure is increased, then volume is decreased. Okay, that's gas law. So if volume is decreased, it means you cannot have more moles in there. Okay, which means you have to go to a direction of less moles. Okay, so go to direction of less moles. Therefore, in this case, it's going to be reactant side, which means your reaction is going to the reactant side, okay, for this. So with pressure, you have to look at the volume. For volume, you have to look at the moles. Okay, and then the catalyst is added, and this is the easiest answer. There is no change because forward and reverse reactions are increased. Okay, if both of them are increased, then it's the same thing. It doesn't really matter. Okay, all right. So these are your 5 different things that we did here to go over LeChatliers's principle. This is one kind of question. Another kind of question that you may be asked, or well, I can ask you, is give all the conditions that will shift the following reaction forward. Okay, so you want to get more product. Of course, you want to get more product. So how will you design the conditions, okay, to make this reaction go forward? So first of all, you do the simple things. Okay, simple things means that you increase reactants. Okay, in increasing reactants, you increase oxygen and you increase sulfur dioxide. Okay, that's the first thing to do. Number two, you can remove products. So as you keep removing the products, you will be shifting the equilibrium forward. Okay, so in this case, the product is sulfur trioxide. So remove the products. And then what you can do, let's see if we can do anything with the pressure here. Pressure, yes, you can decrease pressure. No, you can increase pressure. You can increase pressure because products has less moles, therefore requires less volume. So if you increase the pressure, you decrease the volume. If you decrease the volume, you push the equilibrium to wherever the less moles are, which is towards the products, okay, in this case. And then let's see what else we can do, because we are given delta H. This is an exothermic reaction. So if this is an exothermic reaction, it means that the heat is part of the product. Okay, so if heat is part of product, then you have to remove the product, because that's what we did with number 2 over here, is remove products. So heat is part of the product, so remove heat. And how do you remove heat? You cool the reaction. Okay, if you're following 1 through 4 and you're trying to push the reaction forward and then you add a catalyst, you should be able to use the catalyst to its full potency. But if you just have an equilibrium, then there's no point using a catalyst. I would not write a catalyst here at all, though. Okay. Anyhow, so this is what it is. One last thing I want to mention, and I want to go back to question number 1 here, is what happens if you add inert gas. Okay, so let's just do this one too, okay, because this is an interesting one. So if you add an inert gas like argon, neon, or something like that, the inert gas will be inserted into the whole reaction system, which means to the reactants and also to the products, which means that there will be no effect. Okay, because everything is being changed, not just one side. You're not removing any product or you're not adding any reactant, you're just changing everything. Okay, and so there'll be no effect, okay, for this. So that was one last thing that I wanted to make sure that you understand. So anyhow, that is Le Chatelier's principle. Very straightforward, very interesting.